Cool. So today on the agenda, we've got strings, more strings, and some data structures. So we're going to be covering strings in depth, and we're also going to be introducing a couple other data structures. I'm going to do my overview just real quick. We can go quicker this time because we've sort of dove into everything a little bit. Types, functions, conditions, loops, types, functions, conditions, and loops. Okay, so again, this is sort of the basis of a simple but complete understanding of programming language. Most programming languages will follow just these four. Some may have others. Fortunately, it's just these four with Python, at least for our purposes. So for types, we've covered int and float. We've covered bool, string, which we're going to cover more today. So that's where the bulk of today's material will fit in here. We've covered, let's see, we've also talked about none, the none type, lists, and today we're going to talk about, we're going to introduce dictionaries. We're going to introduce sets, and we're going to introduce tuples. I'm going to put an asterisk next to the ones that we haven't introduced yet. Set gets a double asterisk because it's, it's worth mentioning and knowing that sets exist. It's worth mentioning them. You tend not to use them as much. Well, I guess what I'm saying is you tend not to use them in the same ways that you use like lists and dictionaries and the other types, where the other types are like really central. It's important to understand them for what they are. You'll see what I'm talking about when we get into sets. They're kind of similar to lists. They kind of have some other similarities with dictionaries. We'll talk about that. But their use case, at least for me, you can describe their use case as being if you have a list and you want to turn it into a set. Often that's a good case for a set. You know, when you already have a list. So if you know how to work with lists, you kind of have the bulk of how to work with sets down. And then there are certain set operations that will tell you similarity and difference and other things amongst numerous sets, or amongst two sets, right? So we'll talk about that a little more. So dictionaries are sort of going to be the star of the three types that we're going to talk about today. Tuples are very much like lists, but they are immutable. So notice I just have the mutable types here and the immutable types here. I'll just do this. Oops. Okay, so here's our mutable types and here's our immutable types. So tuples are a lot like lists, but they don't have mutation as a feature. That obviously means that they lack that feature, that power of having the ability to mutate their state without changing the object. But they also, it's a trade-off again, in lacking the ability to change. They gain, you sort of gain the predictability or the stability of having a type whose size you can count on. So tuples sort of have you can sort of guarantee the size of a tuple in a way that you can't with a list. At least sort of philosophically, often you really can guarantee the size of a list, but yeah. Cool. So functions, we know what these do. Quick note on this. Let's just take some quick notes, some reminders. Functions describe, or the function definition describes a general form of an algorithm, right? So this describes a general form. We don't plug in specific values for the inputs. We just define the inputs as names without values yet, right? And that's what makes them generic, right? If I say def factorial of n, I'm not defining the factorial of 4 or something, right? I don't want a factorial I don't want to go through the trouble of writing a whole function to take the factorial of like one number. I want to do the factorial of some number that I don't know yet, right? So the fact that I don't give this a value here means it's generic or it's general, right? It's a general form of an algorithm. And then when I invoke it, invoke the function and supply specific values for the inputs. So I'll if I want to invoke, if I want to know, presuming that I wrote my factorial function, if I want to know actually what factorial of 4 is, factorial 4, and since that was generic when we wrote it, I can supply a specific value when I invoke it, and that's what makes functions useful. We define a generic form and then invoke with specific values, and that therefore we can utilize it for a variety of inputs. Okay, conditions. We've got if, elif, else. Quick note on this. Want to remind folks, there are different ways of combining if, elif, and else together. I'm not going to get into all those rules now. One thing I noticed some people doing from time to time, and nobody in particular this time around, but it's just worth mentioning. Sometimes I will notice folks do this thing where you have, or they'll try to develop like a rule of thumb, like, oh, I should always use an else, or I should always like structure my if, elif, else statements in some certain way, right? There actually are philosophies about this. There are schools of thought around structuring your conditions in certain ways. There are even schools of thought around writing code without formal conditions. All code has conditions in one form or another, but there are some people who are against writing if, elif, and else statements. So you will encounter ideas about this. If you go crawl around the internet, you'll hear people opining about how you should do this, or that all your ifs need an else. For the purposes of this class, if you're a beginner, don't worry about that. Don't develop a rule of thumb. There isn't really a good one. The rule of thumb is that you need to think through every problem individually, and like once you get to the point where this stuff is trivially easy, and then you can challenge yourself with other paradigms and things like that. But don't worry about alternate paradigms for now. Just think through every problem, decide when you have to use what pattern, and just be deliberate about it, and think about just getting to working solutions for now, and that'll do you fine. Okay, loops allow us to loop over code, or repeat code, or iterate. They allow us to iterate. We have two main looping structures, for and while. Went over while loops yesterday. This is sort of the heart of an accumulator pattern. An accumulator pattern right here, right? So yeah, so most accumulator patterns, you're going to write them inside of functions, and quite often you'll have conditions inside or outside of those, and you'll be utilizing, accumulating, and iterating through and referencing all the various types and the various ways that we can do that. All right, cool. So there we go. Nice quick overview. So we get a picture of how everything's fitting together. All right, let's get into strings. Let's get into strings today. Excuse me. So we're going to talk about declaring strings. We're going to talk about string methods and functions with strings. So the string data type. Strings are simply a collection of characters. Python strings are a scalar type, which means that they are immutable. Strings are declared with single, double, or triple quotes. This is this is worded strangely, I think. This is right up at the top. I can find this really quick. I'm going to rewrite this. Single tick or double tick quotes. Oops, I did that in the wrong spot. Scalar type, single tick or double tick quotes. In groups of 1 or 3 in the beginning and end. Okay, I need to actually go through it and like make that more clear. That wasn't as easy as I thought it would be. Apologies, but basically the idea, what this is trying to express is when they say single, double, or triple quotes, that's a little misleading. So you have single tick quotes. You can have a pair of 1 on either end. So this is a string. You can use double tick quotes like this. For reference, this is considered Pythonic. This is the formally correct way. I believe PEP 8 specifies the use of single tick quotes. This is not different at all, double tick quotes. This is my preference. This is my preferred way of writing strings, so you will see me deviate from PEP 8 here. The reason for this is if I want to, let's say I want to have a word with an apostrophe in it, like theirs, right? So notice the apostrophe character, you can see my syntax highlighting gets messed up too. The apostrophe character is the single tick quote. It's the same character. So in order to put in an apostrophe in single tick quotes, what you do is you put a backslash in front of it, and that'll tell the Python interpreter, hey, I didn't mean into the string. I meant just literally put in the single tick character, the apostrophe character, like that. So I find that this is just a little cumbersome, and I use apostrophes enough when I write things in strings that I just like single or double tick quotes better. So yeah, you can make whichever decision you like. Just whatever, you don't have to do the things my way. You don't have to do things the Pythonic way. But for the sake of readability, whichever way you do them that way all the time. Just for your sake and everybody else's sake who has to read your code. Consistency makes for more readable code, probably more than any one given thing. So this is readable if you do it this way every time. this is readable if you do it this way every time. Obviously, there's certain scenarios, like if I was going to use quotation marks in my actual string, I might actually use single tick quotes, so I will break that rule if there's a good reason to do it, but in general, my default is to this, right? And so if you just follow those kind of rules, your code will be like pleasant to deal with and read and write. Okay. So these are single line strings. You can also have a string across multiple lines. So this is a string as well. And this allows you to put in line breaks into your string without putting in a special line break character, \n. If you see me use \n, that is a new line character. So that'll put in a line break right in the middle of the string right there. This is going to allow you to do that just by laying it out in your text editor. So I can just put in a carriage return like this, and it'll read as a new line in my string. So this can be nice for formatting strings. So here we have single quotes. Here I have single double quotes. Here we have triple single quotes. And I mean, can you guess what's coming next? Triple double quotes. So again, whether you're using triple single quotes or triple double quotes, doesn't matter. Being consistent tends to be, again, the thing that makes things nice and readable. Let's see. So yeah, these are exactly the same. These are both multi-line strings, and it's the same. So you might notice that this seems familiar. This is also a multi-line comment. So when you put in a multi-line comment into your code, you are literally putting in an actual string data type. So we actually use strings, multi-line strings as multi-line comments. They're the same exact thing. Notice in these comment switches that I have, where I can turn on and off a whole block of code, I use triple quotes, and that, so let's just go down here, right? So these triple quotes from this line match with these triple quotes from this line, and the line of hashes and the this whole thing is just to make the separation more obvious, right? So all I need to do is just comment out the bottom one, and then if I uncomment the top one, it's going to make a string, and then just keep everything in here commented out in a multi-line comment or a multi-line string. And then if I comment out the top line, it's no longer going to try to make a string. It's just going to see this as a single line comment. And this is print valid code again, right? So this is back to being codable. So that's my thing there. Okay, cool. Okay, so some basic string operators. We've talked about this a little bit. We can add strings to each other using the plus operator. When we add strings, we call it concatenating. It's just a fancy word that means just adding two strings together. So if I said name equals Clark, and I wanted to print, excuse me, hello plus name excuse me, sorry, then what would you expect this to print, right? So I've used concatenation a bit before. We've talked about it a little bit. So hopefully that's clear, right? So this will just add the two strings together, and I think that's a fairly intuitive operation. We can also multiply strings by integers. So if I multiply hello times 2, it'll just repeat that string twice. I think this is concatenation under the hood. I think formally it's even called concatenation. Um, because it's just concatenating the string against itself times however many times you said to repeat it. All right, casting to and from a string. So just about any data type can be cast to a string. Anytime you want to be able to deal with the characters in a data type, which can be a bit of a a weird thing, but let's just look at this. So what if I said for character in stir true? Print character. Let's just look at that. TRUE, right? So string of true is the word true, TRUE, just as it appears with a capital T and everything else, right? False, FALSE, obviously, right? Let's do a number like 4,897. How about this number? 4897. So character is the digit characters from this number. If I try to use this as a number, as an integer, this is not the integer 4, the integer 8, the integer 9, and the integer 7. These are the characters 4, 8, 9, and 7, not the integers. So if I try to like multiply, well, actually, because I can multiply strings, I just went over that. Let's divide it by 2, right? So if they were numbers, we'd expect to see the quotient of 4, 8, 9, and 7 over 2. But if you look, these are strings. These are those characters, not the numeric values, right? You can't always cast a string to another type, but if, let's see, not every string, for numbers, you can cast strings of those numbers to their number, right? So let's say int, and I'll use the string 44 over 2. So 44 over 2 is 22, and this is going to work. And I'm just doing the division operator here just to prove that we can do math with it, and it's actually a number that we can use in a mathematical way. Okay. Let's do float. Same thing. So half of 44.5 is 22.25. And let's just prove that by just actually doing it against an actual number without the number being a float. Cool. Okay, so we can cast floats of numbers to their respective numbers. And I believe we can just do this as well. And this will just, oh, interesting. So we can't do that. That's interesting. Cool. So if we have a string of a float, I guess we can't cast it to an int, but we could cast it to a float and then cast the float to an int. That we definitely could do. Okay, cool. This is a good note. String concatenation only works between other strings, right? So if I have my name is Clark and my favorite number is, I'm just gonna say 6. And if I say print my name plus apostrophe S, favor number is plus my favorite number. So this is going to give us a problem, right? So I'm trying to concatenate sorry, let me clarify which of the values, what I'm talking about here. Okay. All right, so name, favorite number. My name's favorite number is my favorite number, right? So if I try to run this, I'm trying to concatenate these two strings together, which is fine, but then I'm trying to concatenate them with this integer here, with this number here. So if you find yourself getting something like a type error, getting a type error like this, can only concatenate str, not int, or whatever, this could be whatever type, whatever other type here, then just find the offending type and, oops, typed int instead of str. Just cast it as a string like that, and Clark's favorite number is, 6, there we go. Why does it give us, so we have somebody asking, why does it give us a float of 22? When we use a single slash division, even if a number can be expressed as an integer, you have to make, this is back to, if you were designing a programming language, what decisions would you make about this? If you think about it, if I have, like, there are two ways of, or at least sort of two canonical ways of doing division, right? You can either try to express the number fractionally as accurately as possible, or you can express how many times B goes into A, and then you end up with a remainder, right? So that's what floor division and modulo do, the latter. This tries to get as accurate of a number as possible, right? So if I did 40 over 2, we know that this is 20. We know that this could be expressed as 20. But since using a single slash can sometimes result in a fractional value, let's just do 41 over 2, right? So this will be 20.5, right? So since using a single slash can and has to result in a fractional value sometimes, the simple thing to do is to just have it always return a float, regardless of whether or not it could be expressed as an integer. Yeah, it's just sort of a safety. It's just like, you want to count on operations having very consistent, steady, regular, predictable results and behaviors. So since this certain results, certain quotients need to be expressed as floats, then all quotients, whether they don't need to or not, should be expressed as floats. Cool. Let me know if that helps. It's a good question. Cool. I'm going to move on to joining list, but do let me know if that helps or if you're still confused on that. No worries if you are. Right, join a list to create a string. So if I have a list of strings or a list of characters, I can join, quote unquote, join that list into a string. Surprised we're not talking about splitting first. Where is split? Split's all the way down here. Okay. I want to talk about split first. Real quick, let me just open my notes file here. So right up here at the top of my notes file, I have just a text variable that just has this poem in it. And I use this because it has, I don't have any special attachment to this poem or anything, but it just has enough like repeated words, and I have a version with special characters in it, punctuation, so it's small, but it has enough going on that it's a good sort of text toy to play with. So let's see. All right, so let's paste this in. So I've got text equals this, and why don't I'm actually just going to pare this down to just this one first, whatever stanza or whatever. So quite often you'll have a string that you will want to, quote, split into a list. So I'll say list equals text dot split, and split takes zero arguments, or it takes a string as an argument. Let me see if I have this. Yeah. Let's do this part, because this part has periods in it. So, oops. Oh, I hit copy when I meant to hit paste, and I got to do it all over again. Okay. Bear with me. Okay. So this I could split into sentences, right? So if I say sentences list, I feel like I spelled sentences wrong, but whatever. Sentences list equals text.split on periods, and that will split this text into a list containing every portion of the text as its own element, separated by periods. So let's look at this. Hopefully this will be clearer what I'm saying here, right? So what we should end up with is the sentences as their own elements in the list. Where is my output? Show me my output. Okay. Okay. So this is the list we get back. It's maybe a little hard to see down there, so I'm going to paste it in here. Here's those new line characters. So there's a new line character wherever there's a line break. So notice when I have a multi-line string like this, and I put in line breaks in the string just for formatting, they get seen as \n characters. They get seen as line breaks on the end. So for now, I'll just delete these, just so they're not confusing. Cool, okay. All right, so if we look at this, whose woods these are, I think I know. And then that's the end of that element in the string. And then we are on to the next one. His house is in the village, so my little horse and a secret queer. Okay, so I think it's just those three. Let's just find all the periods here. This one, and that one. Yeah, okay. So this splits it up into three sentences, right? So these are the three portions of the text delimited by periods, right? So notice we still have question marks in here, and in order, if we were going to like break on question marks as well, we'd have to do some other work, but this at least gives you somewhat of an idea. So split allows us to take in a character to split on, and well, it'll split on that character. Let me comment this out. So split optionally takes zero parameters, takes no parameters, and if I take no no arguments, I get words. So I get every word isolated in the list. And so what it does is it'll split on three things: spaces, tab characters, and new lines as well. And if you look, this is just a list of all the words where each word is its own individual element in the list, right? So whose, then woods, then these, then are, right? So this gives us just a list of words. So this is really handy if I want to say for word in text dot split. That's just going to give me every word, and I can just print word here. We got a couple questions here. Can the delimiter be spaces or number of characters? Hopefully this answers your question. You can put in a space like this, but then it will ignore new lines and tab characters as well. But yeah, your space or your delimiter can be any character in the string. If you do want words, the best thing to do is to not pass an argument to split, because that will actually give you words. Hopefully that's clear at this point. Can you use the split method? Can you use the split with multiple special characters simultaneously? You know, I've always gotten around this by just looping, essentially. But let's ask Python. I'm going to come into my terminal and do a little exploration in here. So I'll show you how to ask that question to Python. So if I say, let's say help stir dot split. Actually, no parentheses after split there, because we want to pass the function, not the invocation. Takes a separator, none, max split equals -1. And then so from here, this is going to tell us, sorry. Okay. So from here, I feel like my terminal's kind of being buggy. I think there's text back here that there's not showing me. This terminal is a little bit, I don't know why this terminal extension works on every other computer I've tried to install it on, except on this particular computer, it's kind of buggy for some reason. So I just kind of live with it. Okay. try it again. So it says returns a list of words in the string. Use separator, use the sep for separator as the delimiter string. Sep the delimiter according which to split the string. Maybe I'm reading that wrong. So none, the default value, means split according to any white space character and discard empty strings from the result. So this is a pretty clean way to get words. Max split, maximum number of splits to do. The default is -1, which means that there's no limit. So yeah, I guess if I wanted to only split like 2 things or something, then and it could split 50 things, and I could split like the first 2 things by passing a number there. So it doesn't look like split supports multiple characters at the same time. So the way I've done that, I really wish it would, because it kind of makes sense, right? But the way I've gotten around that is to go through. Well, if I do split on periods here, then go through each of those strings within, and then split those further, and then take the elements and kind of unpack them into another string. But it's a little bit, it's not hard, but it's just kind of a little busy worky kind of. Yeah. Anyways, cool. Okay, so this is how you get words, and this is probably the most, like, one of the most useful things you can do. To give a quick answer to your question, though, about using splitting on other characters, you can actually use replace in conjunction. So since text is immutable, let me just copy this and do something else. What you can do is I can say text dot replace question marks with periods. And I think that'll give me oh, what is it for strings? String object has no attribute replace. It's dang it. I always get this mixed up with list. Okay, so we'll do IPython 3. We're gonna learn about these anyways. This is just a weird thing where I always forget this, and I always get it conflated with lists. So let's look at the directory for string, and it's going to be, oh, it is replace. REP. Oh, I misspelled it. That's what it was. I was like, I'm sure it's replace. I misspelled it. Okay, y'all caught it before I did. Thank you. So if we look at this really quick, whose woods these are, period, right? So on this string, I could dot split on periods, and that would split on all the sentences like that. Equals this, right? Important to note here that, so, well, I guess I'll put it to you all. When I call, we know what sentences is. I just printed that off. That's, well, actually, I didn't print it off. Let's be clear about this. So the question is, this is going to be our sentences split out, but the question is, what is the value of text? Does text have its original question mark in it? Or no? We ran replace question marks with period and then split that. So is text now a list? Does it have a question mark in it? So we'll treat this as a mini breakout. So I'm not seeing anything yet. The text does not change. Text stays the same. Strings are immutable. Mm-hmm. Good one. Yeah, replace essentially returns a copy with the changes. Yes. So that is what makes strings immutable. So if I print off the original text variable, it will have the original value. Cool. So this is split. So think of split. We have the well, I guess we're going to talk about the list function as well. Let me get text in here. So you can think about split as one of the two ways you have to convert a string into a list. Split gives you the control over which character to split on. One quick thing here to note: if I split on periods, notice that there are no periods in the elements of the list that was split. If I split on white space, which is the default behavior, it removes all white space from the list. So whatever character you split on is not represented in the list, in the elements of the string in the list. That split returns. The other way, let's do this. The other way to convert a string to a list is to just use the list function. Just cast it as a list. This is going to have different behavior, though. This is a very different thing. You do use a string as an input, and then you get a list as an output. But we'll see. This is going to give us a list with each character in the string as its own element in the list, right? So this is every single character as its own element. So you don't tend to see this as much. You tend to see converting a string to a list tends to make more sense or be more powerful with a split. Okay, so let's pick up where the material wanted us to start here, which was with join. Okay, so join is sort of the complement to split. So split we call split on a string, and it gives us back a list. We call join also on a string, and we pass it a list and we get back a string, right? So if I say words list equals text dot split, words list equals text dot split, and then I can string dot join words list. I'll do it this way first. String again equals string.join words list, right? So join's argument is a list of strings, and we call it on a string, right? So in this case, I called it on an empty string. This is a string with nothing in it. And look at what we get. We just, I mean, since split removed the characters that we split on, when we joined them back together, we just got one big, ugly mass of text with no spaces in it. So join allows us to specify a separator, but we specify it here, right? So if I want spaces as a separator, I'll do string with a space in it. So string space dot split, or excuse me, dot join words list, and then that will separate each element in the list with a space. Now I can put in whatever I want here. So I could do dash exclamation dash dash exclamation dash. This is going to look weird. So this separates every word with dash exclamation dash dash exclamation dash. Kind of looks like a bridge. Okay, bridges and things. All right, so that's how join works. So they split and join often go together, and you'll often see when we'll often use split early on in a function, and then to split up some string, do something with the words there, and then maybe accumulate some of the words into a different list, and then join that list back into a string. So that's a common pattern. So when you see one, you're probably likely to see the other one soon. So each one sort of undoes the operation that the other one does. It's kind of funny because they don't feel the same. This was an issue that I had when I was learning these. They really don't look the same. They don't feel the same, even though they really go together. So here we're calling this on a variable. Here we're calling join on an empty or on a string with a space in it. This just looks off somehow, but it's important to remember that these are both string methods. These are both methods on strings. Yeah, so join will be called generally on a string that we supply whatever spacer in there that we want. So if we wanted to do underscore separation, we could do something like that. And then split will typically have this form. So again, I've said this before, but I want to reiterate this. Join's argument has to be a list where all the elements in the list are strings. So if we dot append 57, an integer on this, we're going to get an error when we try to run join. So it'll say type error can only join an iterable. Cool. So that's split and join. This is a good point. They're using, actually, I can go back up and why don't I just do what I just did. If you do have something, we'll just put this big old number in there so it's easy to see. If you do have something in the list that won't work with join, quite often you'll see the map function used here. So map. So what map is going to do, I really like map. It's actually kind of a replacement for a comprehension or a for loop. So what it does is it maps a function that's already written somewhere. It maps each element from a collection to the argument of the function. So essentially what I want to do is pass every element from words list to string, and then get you can think about it as a list. It's actually a generator, but get a list out where the element in that list is the result of whatever the function returns when each element in the collection is applied to it, right? So here we have a collection. We want to pass each element in the collection to a string to make sure it's a string. So we want to map the string function to each element in this collection. So notice this is str, this is the string function like this. This is the first time that you've seen, well, technically I just showed this with help, but this is an uninvoked function, right? So you need to keep this in mind. If you're going to use map, its first argument is a function that you do not invoke, right? So I don't want to invoke string. I don't want to put the parentheses after it. If I put the parentheses after it, it's going to call or try to call the function. So I want to leave the parentheses off and just pass just the function name without the parentheses, and that's called an uninvoked function. So we pass an uninvoked function, and then map knows, okay, so this is the function that I'm going to invoke under the hood. It's so map will take care of the invocation under the hood. So map is kind of a weird function. I mean, it's kind of different than some of the functions that most of the functions that we've worked with thus far, but it is really useful, and you will very often see it applied inside of the argument of join like this. So join, like string.join map stir to some list where some of the elements in that list might not be strings, right? And this is to just avoid that error. So if I run that, cool. So string slicing. None type, wait, did I get an error? I did get an error. None type is not iterable. Wait, do I need to, I don't need to do this, do I? Huh. Well, I'll be. If anybody sees the error that I'm getting, feel free to point it out. Oh, I'm silly. Of course. Of course. I was setting it equal to append, which I should I should just know that append returns none, right? Append doesn't return a value that's useful to us. The append's utility is in that it alters the list, right? So now we have whatever 500 million on the end of this, or whatever it is. Okay, cool. Sorry about that. Did that explanation of map help you? To the person asking for an explanation for map? Returns a copy with the changes. Okay, cool. Looks like there aren't any other questions. Okay, so string slicing. So everything you learned about list slicing, if I had a list, and I wanted to list sub 3 to 5, 6, I don't know. So this will slice the list by its elements. String slicing will slice a string by its characters. So let me just grab this. So text is this little string. And let's say I want to just, I want to slice from woods to, I just want to slice out these two words for whatever reason. So I can do 0, 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 6 to 17. So text sub 6 to 17. We'll see if I counted correctly. So strings have indices just like lists. The indices just correspond to each, oops, I forgot to print it. They correspond to each character rather than like each word or something. So the characters are the elements of the string. Interesting. I'm miscounted a little bit. Oops. So wait. 0, 1, 2, 3, 4, 5, 6. Oh, right, because the first character is a new line character, so I was missing one there. So that should be 7 to 18. Okay, cool. So the elements of this string are the characters in the string rather than like full list elements like this. Each character has an index which describes its location. Indexing is zero based. The same kind of indexing and slicing rules that apply to lists apply in exactly the same way to strings, except that instead of full elements, you get just single characters. Unless, of course, you're doing a slice, then you can select a portion of your string. And slicing, the portions for slicing are start, stop, and step. This says start and skip. Start, stop, step, beginning, and floof, whatever you want to call it. But I usually call it start, stop, step. String membership. So if you all recall checking membership in lists, we did 22, 33, 55, and if I say print 33 in list. Oh, what's with me today? That's a weird one. Okay, so true, 20, 30, 33 in list, right? So same thing with strings. So if I say vowels equals A-I-O-U, C equals U, if C in vowels, print, or actually I'll just print C in vowels. We just do a test for membership. Easy. But we can also test a substring. So if I want to see if AEI is in the string, that's true. AIE is obviously going to be false. So I could test for a word or a substring or a single character, but the order matters, right? So AIE, the string contains those characters, but not in that order. So it does not contain the substring AIE. So that's an important thing to know with string membership. Cool. We're about at the halfway mark. Let's reconvene at, for me, it'll be 8:11, so 11 after the hour. All right. Hopefully everybody's settled back in and ready to go. Cool. So a couple things I'm going to kind of gloss over here because I want to just keep us moving. So replace, we just kind of looked at. I ended up just using it in answering somebody's question earlier. So replace, again, just to reiterate, right, doesn't actually cause a change in the string. Just replaces a given substring, a single character, or a given substring with an element that you pass. So it takes 2 or 3 arguments. The first 2 are the element to replace, and then the element to replace it with. And then the second one is the number of times to do it. That will be the limit. I think, yeah. If you, of course, if you don't supply a third argument, it'll just replace all occurrences of whatever you're looking at. Enumerate. So this brings me to iterating through strings. I'm going to assume that this is already kind of, there's some understanding around this. Excuse me, gosh. Get hiccups right when class is going, sorry. So if I iterate through this string text directly for character and text, I can absolutely do this. And I can access each character in the string. Right? So what do you think is going to happen if I enumerate? Works just like it does with lists. IDX and CH R whatever C and enumerate text. So this is going to give me access to the index as well as the characters from the string. Cool, and we've got a breakout. And you didn't see the solution. Okay. There we go. And I'll put 5 minutes on the clock here. Somebody's mic is on. If everybody can just go check real quick and make sure your mic is off.